All right, recording, rolling. We're in the last about 7 minutes of class. We're gonna score this thing. Gonna score your procedure. All right, you guys ready to score yourselves? Say I did. All right, so I think this is scored out of 7. I think is what this rubric is. All right, so everybody has the same question. What's the firing speed of the launcher? And I said you could only use a meter stick, or if some of you guys have a trundle wheel, that's okay too. So meter stick or trundle wheel. Okay. Okay. All right, data gathering procedure. I have 4 steps. Look at that, 4 steps. So the first step is just a brief description of the setup. Set up a ball launcher at the top edge of a balcony and aim it horizontally. Boom, that's the entire setup. Right? So if you wrote that in your procedure, give yourself a point. Second point is measure the height of the balcony with the meter stick. All right, so I use the meter stick to measure the balcony height. Boom. Walking around, I think most of you guys got about 4 meters or so. So you guys get pretty close to 4 meters, right? So some of you guys used different heights. Some of you guys went halfway or something. That's okay too. Yeah, different little stuff. Launch the ball and spot where it lands. Measure the horizontal displacement with the meter stick or the trundle wheel, and record that. Right, so there's your third point for measuring the horizontal displacement. And step 4, repeat several times and find an average. If you wanted to find an average of different, like after your calculations, that's okay too. Okay. So multiple trials, as long as you had some kind of mention of multiple trials. So there's 4 points so far. All right, you guys good? Let's go. All right, remind you guys what this is looking like on the poster. Right. So you measured this drop height, you measured this horizontal displacement, and the setup is you just aim this horizontally from the top of the edge. So that's what we got so far. That's the entire procedure. All right, now analysis time. Analysis. This is going to be equations in this case. We're going to do. All right, so AP could ask you this exact question. This is exactly what they'd be looking for. They would want you to start with h equals 1/2 gt squared and rearrange that and solve for t. So 1 point for use of correct kinematic equation to solve for t. That's basically this red bit right here. Right? So all this red stuff, right? Which is the same thing you guys did for your reaction time lab. Right? You drop the roller, your friend catches it. Say, oh, the roller fell so far, it's like drop height h. No Earth's gravity field. I can solve for the time. And now, as long as you were launching it from the same height, it should have been the same time over and over. Okay, so you don't need a stopwatch, which wouldn't even be as accurate as this method right here. Okay, you guys got that? Okay, so you have to start with this first step and then rearrange it and solve for t. Did you guys get a little bit less than a second to fall 4 meters? Because it would take 1 second to fall 5 meters, wouldn't it? So a little less than a second to fall 4 meters. Okay. So that's a point right there for that. Okay. Then to determine blast speed, just take that horizontal displacement and divide by that fall time. Boom, just like that. That's it. Right? How far did it go across divided by how much time? Because that is a constant velocity value, isn't it? Like if you know how far it went, d, you measure that with the meter stick or a trundle wheel, and you know how much time that took, right? Then just divide those two, distance divided by time. Okay. Do you guys see how, like if I take a picture every second, see how they're equally spaced? Right, so it's going constant velocity across the field, which as long as you aimed your cannon horizontally, then the horizontal velocity is the blast velocity. It's the same thing, which would be the answer. Right. Oh, okay. And then if you want to put it all in one giant master equation, then here's the rest of the poster. Okay. Right. So here's the blast is that horizontal displacement divided by the fall time. The fall time is this whole funny square root expression. So if you divide the two, guys, if you divide by a fraction, can you flip the fraction and multiply? You can do that. Okay. So if you want to be really fancy about it, here's the answer in terms of variables. Here's horizontal displacement, here's drop height, here's gravity field. Yeah.
Do we have to put like our work of getting like the h to get g?
Yeah, okay. Yeah, guys, AP would expect you to start with this very top step. You have to write the h equals 1/2 gt squared. Otherwise, you don't know where it's coming from. Or if you change this assumption, like what if you didn't blast it horizontally, then this wouldn't be the first step anymore. It would look a little bit different because you have to have the V not T bit in there. Yeah, so they would expect you to start with that and then move down. Oh, here, really what this from, AP usually wants you to start with an equation somewhere from this page. So maybe it's good to get familiar with this. So far in this class, all we've done is these first, you guys see these are the 3 kinematic equations. They're a little bit different order. They look slightly different. Okay, but from that page. So you could start with this, h equals 1/2 gt squared, and then work your way from there. All right. All right, and then, okay, so it's only 2 points on the analysis. Final point, this is point number 7. In the conclusion, the blast speed of the launcher is so many meters per second. And I was walking around checking. It looks like most of you guys had somewhere around 8 to 10 meters per second. And it looked pretty consistent from team to team. If you got something about 8 to 10 meters per second, then I think you're right in line. Okay. You guys good? Right, so that's just the whole thing was 7 points. Go ahead, score yourself out of 7. Throw that in the gray tray, and I will give you guys points for doing that. Wrap on today.